All right, electronics and arcade enthusiasts, we are back again at the bench. And today I have just unboxed my next job, and it is a CinemaTronics set up. It looks like a whole CinemaTronics electronic setup. You have the monitor chassis here, and this was separate. It just goes over that. So we have a monitor chassis, and we have a rip-off board set. Now, it says good here, so I take it that this board must be good. The CPU board must be okay. But the sound is not good. So yeah, apparently the sound does not work. And I haven't looked at these hardly at all. I just got it out of the box just now, so I haven't looked at nothing. Yeah, so CinemaTronics. So we'll go through this. This needs to be cleaned up. I'll remove the high voltage parts. Wash the board really good. Start with a nice clean board set. And I like to remove these. I don't want to get this stuff wet. So that'll get removed. We'll wash this really good. Do some maintenance. We'll replace our regulators. And we'll check the sockets. We might want to replace these sockets. Doesn't look like anything's burnt up on this, which is nice. I don't see any fried resistors over here. We'll make sure that those aren't open. These big guys aren't opened up. And just kind of test everything out. Another CinemaTronics. Okie doke. Alright, first things first, we're going to clean this baby up. Actually, the first thing I might do is just plug that board in and see if it flashes. See if the LED flashes and goes out. That'll tell us if that board's good. That'll tell us if the CPU architecture of the board is working. So that'll actually send a signal to this, which is what we need. All right. And if worse comes to worse, I do have a working CinemaTronics CPU board, so that we can use to get this guy going and then work on that at a later. We'll get there when we get there. Right now, I can just plug that in, see if the light flashes. If the light flashes, we're in good shape. Okay, and go figure. These guys blew up. That one is blown up. That one is blown up. Any more on here blown up? These are probably, well, they're 35 volt caps. And these are 18 volt regulators, so these should not be blowing up. It's not like it's a 25 volt cap with 19 volts being on it. So those things shouldn't be exploding like that, honestly. But they do. They love to blow up. So all of the voltage filtering tantalum caps are going to get replaced, as well as this one. I've seen this one explode. I'll replace this guy, these two, of course the ones that are busted. Probably do this guy right here, and this one's a signal cap. That should be okay. This one over here should be okay too. That one right there. I'm not replacing that one. But all of the blue ones, all of the little blue ones, they're all 2.2 microfarad. I'm going to change every one of those with electrolytics. All of these guys. I don't know if that's a 2.2 right there. Yep, 2.2. All of those guys are getting replaced. Yeah, looking like an awful lot of green corrosion on right here. I don't like that. See that? A lot of green. A lot of green on this board set, to be honest. Alright, I'm going to get at it. I'm going to start working on this thing, remove this stuff, get this thing cleaned up. See if I can't scrub some of this corrosion off of this thing. Alright. Alright, really quick, I have my meter ready to go, and we're going to watch the LED. And on. And it does flash and goes out, so apparently it is working. And that is it. Alright, we got this guy cleaned up now. I have put some deoxide in the pots and worked them good and kind of scrubbed the thing. I actually scrubbed it with simple green, got all the dirt off of it, and then I dabbed some toilet bowl cleaner on it and kind of brushed it, got it foamed up pretty good, and then rinsed it good to try to get some of this corrosion crap off. It did a good job getting all that corrosion off of there. It's pretty clean now. I don't see any more green. If you remember, if you saw, there was a lot of green around here. So we got all that nonsense off of there. I got all of the caps, all the little blue caps pulled out of it. I got my replacement parts ready to go. Cleaned these little heat sinks up for my new voltage regulators. I got all the old regulators pulled out of it. So I'll go ahead and start repopulating. I don't see anything else blown up, so it should be okay. Alright. Alright, just putting in the new regulators. And I'll go ahead and do one on camera. You want to clean all of the old paste off of this thing and just kind of smear some of this on there. Doesn't have to be a ton. And grab it by the sides, kind of pop it down into here. Make sure it gets set into that little channel there. It just goes like this. This is the positive 18 volt one. And it goes over here. And this is in, common, out. Positive regulators are in, common, out. Negative regulators are common, in, out. So if you don't know which way it goes, you can just look at the traces on here. This is the common, and it's going to the middle. This would be common. This is the positive 15 volt, and the input comes around and goes to here. So the side on this side is the input. So it goes like this. In, common, out. Just like that. And set it down on the board like so. And it falls through. And just keep trying it until it doesn't fall, I guess. Let's try putting this red wire around there to hold that. See if that works. Okay. And we'll do one leg. And we'll check it top side. And it is all the way down good, so let's just go ahead and solder it down. Alright. Let's go outside and inside. And clip. Clip all three down. There's that one. That's all of those. Let me put my paste up and continue. I've got my little 2.2 microfarad caps going. I've got a couple more to put in. I got to do the sockets yet. And that'll be it. And I'll put the this stuff back on it. And this thing will be ready to test. Okay, and we are reassembled. Got the sockets in there. I have not scrubbed the flux off the back of the board yet, so I will have to do that yet. But yeah, we are good to go. One thing I am going to do is just kind of probe around on these preamp deflection transistors and make sure that none of them are shorted or open. And yeah, then we'll be ready to go. Put these chips back in the board. Go from there. Okay, we're going to do a really quick transistor check. With this guy, I've got nylon screws holding this thing down. Except for this one is metal. And that's because this grounds that. It grounds this thing. So that one's metal. The others can be nylon. Okay. Down in this area here with the transistors, if I can do this, I'm going to have to raise this up so that it has clearance. Oops. Okay. I'll move this guy over here like so. And do that so that you can see that a little bit better maybe. There, how's that? How about we just do this? There. Okay. These are NPN transistors on the ends over here. And then you have PNP, 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 and PNP, and PNP right. Where are you? Here's this one right here. Okay. And then we have some current limiting transistors, basically current shunts. And those read different, and I'll show you how they read. First, let's do the two NPN transistors. So we're going to put our P lead, our red lead on the base, which is the center one. And there's the center. And there we go. There's a reading. And here's a reading. That's good. Move over to this guy. We have a reading here and a reading here. That's good. Now we'll do the PNP ones, and we're just switching our leads. The middle, the N lead goes to the middle, the base, and then either side we get readings. Good. Same over here. Good. And then up here. Good. Good. And here. Good. Good. All right, now these drivers, these current shunting transistors. This one right here is a NPN. Good. Good. And then this one is also NPN. Good. Good. All right, now there's two right here. One of them is a NPN. We'll try this one first. Okay, this is the PNP transistor, and that is the reading that you're looking for, 0.0 something or other. And the other side should be good. Okay, yeah, and then this one is the low reading. So that's actually the NPN. This one's the PNP. There's your low reading and then your regular reading. And then over here, same thing. You have a regular reading and a low reading. And then on this one, you have a low reading and a regular reading. Like that. Now, preliminarily, they look good. That doesn't mean that they are 100% good, because you can't really test a transistor properly in circuit like that. You can get a good gist that they're not open, but you really don't get a good gist whether one of the junctions is conducting both ways. And that is something that if this thing doesn't work, we have to do a more in-depth transistor check. That means removing transistors and actually checking them out of circuit. But this gives you a good baseline to start at. Nothing's shorted. There's no shorts on here, and that's good. So we can actually hook up and see what happens with this. Okay, this thing is all hooked up. I have the deflection amps, the deflection transistors plugged in. The yoke is plugged in. The board is plugged in. And all I am trying to do is hear this yoke chatter. I've got the high voltage in a glass. Okay. We are all hooked up. So let's go ahead and fire this thing up, see what happens. I'm going to pay attention to, I'm going to have this focused on the yoke, and I'm going to look down here and keep an eye on the fuses, if I can do this. Okay. All right, here we go. Well, I don't hear any chatter at all. The fuses are not glowing. Okay. There's no chatter, there's nothing going on. Okay. All right, I didn't hear it. I heard nothing. I heard no signs of life at all out of this thing. So I think what I will do is go ahead and try a different LF chip. See if that makes a difference. Okay, I switched out to a known working board just to eliminate that. And I've just kind of been probing around a little bit, looking at some voltages, and we turn it on. And it's funny that we're not blowing any fuses, so we don't have shorts. We have opens of some sort. It's got to be. But if I put this is ground right here. If I come up here, I can look at, I got 90 volts off of the high voltage unit. So I'm pretty confident that so far, that the high voltage unit is working. There's our 90 volts. And we have a series of voltages here, but there's, on the collector of this preamp, there's no voltage. Half a volt, 0.7 volt. There should be more voltage on this, I believe. I think this should be like 23 volts or 24 volts or something like that. If not more, there should be voltage here. There isn't. Yeah, so, yeah, it looks like it's schematic time. try to hunt down and find out what exactly is going on with this thing. We have our, our 20. This is our negative. This is ground right here. So here we have our negative 23, our positive 23, negative 15, this must be negative 23, and then this is negative 15. That's off of the 15 volt regulator. This is off of the positive, which that's 0. Why is that 0 volts? That should be 15 volts. Why is that? Oh, yeah, in, common, out. This should be in, common, out, and this is common. Okay, I got to check into that. This is the 15 volt regulator, and there's no voltage on it. That's common, but this is the output pin right here, and there's nothing there. So what is going on there? I got to figure that out. Okay. Yeah, I got this. I got the meter on diode, and if I put my red lead on ground, and I touch the output pin of the 7815, it is grounded. 15 volts is grounded. So what uses 15 volts? It's the op amps. So one of these op amps grounded out. I don't think it's the I know that the LF switch uses 15 volts, but I don't think that is it. Let's check, see if we're still shorted. We probably are. Yes, we are. I guess I'll just, oops, just drop this. I'm going to go ahead and clip out these op amps. I don't know which pin is actually 15 volts, but whatever. I'm just going to clip them out. Okay, let's see if we're still grounded. I only clipped one side, and we'll see if it's still grounded out. Still grounded. Now let's clip the other side. Okay, I've got one of them cut out. Let's see if we're still grounded. Still grounded. Let's try the other one. Okay, got both of them out now. Let's see if we're still grounded. And it's still grounded. What the hell is grounding out 15 volts? I think it's time to look at the schematic and find out. Let me put this thing here. Man, it might be this diode right here. Let's cut that thing. try it now. Yeah, it's still grounded. I don't know. I'm going to have to look at the schematic and find out. Follow the 15 volts around and find out where it is shorted. Well, I found the short on the positive 15 volt rail. Take a wild guess. Tantalum capacitor. If I can do this, I will show you the short. It's one of these orange guys. And come on. There it is. See that? 003. Orange cap bad. Alright. Well, I'm going to replace those with some electrolytics. And I'm going to go through and remove every single remaining tantalum capacitor on this thing. Replace it. Replace my 2 op amps that I removed. And then see what we got. And I'm going to make sure that my 15 volt regulator is not shorted. This should be fine. Okay, I got her hooked back up. You know, anode cup is in the glass. Things plugged in. I got repopulated. I just want to hear this yoke chatter at me. Original, the board that came with it, I got plugged back in. And we need to plug this stuff in. Okay. And once again, I'm going to watch the fuses because now that we've got all of our voltage going, if that LF 13331 is no good, it'll pop the fuses. So I want to watch my fuses. And we'll see if this thing starts chattering. I hear it chattering. Fuses seem to be okay. Yeah, it sounds good. You can definitely hear it chattering. No fuse blowage. Nice. Alright, let's go ahead and turn it off. Pretty sure it's working. So I'm going to hook this thing up to my tube over there. And we'll see what it looks like. Okay, we got the rip-off board set hooked up. We got the monitor all hooked up. And it is time to give it a fire up. Here it goes. I hear deflection. Not seeing anything. Be the brightness pot, perhaps. Can't really get to it. It's got all kinds of deflection, but I'm not seeing any. There's nothing on the screen. I mean, there's static. There's high voltage. I just got to figure out what is going on. There's no brightness, no picture. All right. Well, we'll figure that out. Well, I switched back over to this board because this thing went crazy bright and then died. Killed both the fuses on my AR, on my power supply. So I put new 4 amp fuses in it, and I replaced the LF 1331 analog switch and this thing went bad. And it's working good. Star Castle up on there. Looks good. Needs a little adjustment, but no big deal. I'm going to put the rip-off board set back on it and make sure it's good. Okay, the rip-off board set is back on. And let's fire this up and see if it works. I hear chatter. It doesn't sound like the same level of chatter that I get from the other board. Okay, I'm not getting anything. Just checking out my fuses. They're still okay. This board is not... I'm going to turn it off. And when I turned it off, I saw a flash over here. This board is not putting out an intensity signal is what's going on. So I'm going to, in real time, get this out of here. Boy, I can't see without my glasses. And yeah, there's no broken pins. No pins broken. Let's grab this board again. And this is the Star Castle board. Just kind of set her right there. Plug it in. Plug this in. Turn it on. Make sure it's not ground. Okay, good to go. Turn it on. Yeah, here it comes. See, this board works fine. It puts out the rip-off board is not putting out an intensity signal. It doesn't look like. So, okay. That's why it is almost imperative. Well, it makes it a lot better to have working stuff to test this stuff with. So I know this monitor is good to go. I'm just going to let this thing run. I'm going to let the monitor run. This thing blew up and killed my fuses. That's garbage. So it's got a new analog switch. The DACs are good. All new caps. All new. I replaced all of the tantalum caps, I should say. I replaced all of the voltage regulators. Sockets, op amps. One diode. Yeah. I got rid of every one of them tantalum capacitors. And this thing's rolling. Looking good. It just needs adjustment. These things would adjust right out perfectly. But I'm not too worried about that. I kind of like it a little bit smaller. I don't really need to drive this thing that hard. So I'm just going to leave it as it is. And the end user, the owner of the thing, can adjust it to their liking when they get it. I'm just going to let this one run, and I'm going to end this right here. This is the monitor repair, and I'll do the rip-off board next. So as always, we'll see you later on that one. Thanks for watching this one. And yeah, it's just been another classic arcade repair. We'll see you on the next. Bye for now. Okay, well, after I ended the video on this monitor last night, I had a burn-in failure. After about 2 hours, I came out and I noticed that the screen was kind of ballooning. What do they call it? Blooming. And I knew that was in the high voltage circuit. And I was like, okay, well, weird. I just let it keep running. I went inside. This was last night. And I came back out after about 2 hours, and it was dead. Blew both my fuses again. My negative 18 volt regulator was basically burnt in two. Okay. So I went through and everything in that section, that high voltage section, including all the caps that filter the 18 and negative 18 volts. I went ahead and replaced those caps, and I reflowed everything because I noticed when I got to looking at this again that a lot of the solder was not great. So I reflowed the whole bottom of the board. Now, okay, I got it put back together after that, after doing the caps and everything in that section. Fired it up, and I lost vertical deflection. I just had a line through the middle of the screen. So the vertical section's up in the corner. So I went ahead and I replaced this transistor because it was open. And I replaced the current limiting transistors, which are that silver can there, this silver can here, those two silver cans, and that 3906 right there in the middle of the screen. Those are the current limiting transistors. So I replaced those guys, reflowed everything, and ran it for about an hour last night after that without issue. And it's been on for about an hour this morning. And I'm monitoring my negative 18 regulator. And this thing's solid now. No more blooming. I've got the screen kind of small, you know. I don't need to drive it that far, that hard. But it's not doing any more weirdness. Just a little update. It did fail. And I didn't even bother putting the casing back on that. I will put that back on there, of course. But yeah. This thing really needed and this transistor over in the corner, this is great. When I replaced this transistor, I was able to just pull that out of the board without desoldering it. That's how bad the solder was on the bottom of this thing. So yeah, I went through it and I reflowed the whole bottom of the board. Yep. Alright, now I'm going to end it after this little update. I did have to do some rework after the burn-in failed. But yeah, it's good to go now. I'm confident now. It's been 2 hours. My negative 18 is right where it should be. Nothing's burning up anymore. So now that's turning off. Now I'll go ahead and call it good. I'm going to leave it running for at least another hour. And then I'm going to inspect the bottom of the board again and see if there's any hot spots or any, because it really burnt, that negative 18 volt regulator burnt up. I mean, it burnt right into two pieces. It was crazy. So yeah, I figured it must have been one of the caps filtering. It must have been leaking to ground. That had to have been what was going on. And it is good practice. I should have just replaced all those electrolytics when I did it the first time, but oh well, I tried to skimp, I guess. But anyway, that is it. Now we're going to end this thing. And we'll see you on the next Classic Arcade Repair. Thanks, and bye for now. All right. It is time for burn test failure number 2. The same exact thing happened. This time it was more catastrophic. This thing started sizzling. My 18 volt, negative 18 volt regulator died again. So what I ended up having to do is I ended up having to convert this to run on a Keltron. I removed all of the high voltage stuff, put in this connector, connecting everything, and this is now, the deflection works great. The deflection board works great. This thing, I don't know what was feeding back, and something was absolutely destroying that negative 18 volt regulator. And then the last thing I heard was that tripler was sizzling, and I shut it down quick and just stripped that stuff all out and converted it to using the Keltron high voltage. And that works good. It looks perfect. Looks beautiful. So, yeah, unfortunate. It's unfortunate, but it is what it is. So, and I do have the ripoff done, so let me plug that in. Yeah, and that's the ripoff board. And there's ripoff. Ripoff provides a lot less chatter. There's just not as much going on as Star Castle. Yeah, but that's unfortunately what I had to do. So, and I do have a video repair series on this guy. It just had some stuff wrong with it, but yeah, this that's what I had to do with this one, is strip out all of the high voltage stuff and convert it to use a Keltron monitor or Keltron high voltage supply. So that's it. Hopefully that is the end of this, and I know it will be, because I know this high voltage unit's fine. And now I won't have no more high voltage killing. So, yeah. Alright. Well, that's going to end it now for this. And unfortunate that I could not save that high voltage section, but just not to be. Alright, we'll see you next time. Bye for now.